Okay, here we go with the last experiment. Let's have a look. So the last experiment is almost identical to the previous one, where we're using the same hydrogen gas inlet. We're using copper oxide. We're going to burn that copper oxide in the presence of hydrogen gas. But this time at the end, remember how there were these, let's just get a blue pen here. Remember how there were those like little water droplets developing here? Okay, and eventually when we carried on burning and we carried on pushing the hydrogen through, eventually that water ended up leaving. So this is just a little bit too big for my liking. The water eventually ended up moving out through this tube here. This time, the water vapor as a gas is going to move through the tube, but this time we're going to send it into a U-tube. Okay, this is a U-tube. And the gas, now as soon as it gets down into this sort of mixture of ice and water, that water vapor, that water as a gas, is going to condense. It's going to turn back into a liquid, and it's going to start pooling, and it's going to start collecting in this U-tube like this. Okay, so this is the only difference between the experiment. We're still going to be forming, let's see if we can get a nice orange, we're still going to be forming that copper metal over there, except the oxygen is going to combine with the hydrogen gas. The water vapor is then going to flow down this pipe over here. It's going to then cool because of the ice. It's going to turn into water. Okay, so we can use this experiment to determine the formula of water. Let's just recap a few things. Okay, so we have the mass of the dish. The mass of the dish before I put the copper oxide on was 23.73 grams. Okay, we got the mass of the dish. This is empty. Okay, empty. Mass of the dish. This is with copper oxide with the black compound put on top. This gives me 26.96 grams. Then we have the mass of the dish. We have the mass of the dish at the end of the experiment. Okay, that's, remember, then just with copper present, that is 26.32, and then we've got the mass of the water now. Mass of the water. Remember, the water is collecting in this U-tube here, and we can take that U-tube and we can go and measure it. So the mass of the water. Obviously, we'd take the mass of the U-tube first, and then we take the mass of the U-tube with the water. We'd minus the two, and what we get is 0.72 grams. Okay, now we've got this new value here, but these all are the same. So let's just quickly clarify. If we wanted to get copper, we take the mass of the dish at the end, and we take the mass of the empty dish. So we say 26.73. This is just a recap from the previous experiment that I spoke about. 26 point. Oh, I've got this mixed up. Okay, so 26.32 minus 23.73. Those are those two there. And this is the mass of copper, so it's 2.54 grams of copper. Okay, let's just circle that nicely. Then we wanted to work out, well, if I've got copper oxide here, and that's 26.96, and that's 23.73, I can then work out 26.96 minus 23.73. I then minus those two, and that gives me 3.18 grams of copper oxide. So if I've got copper oxide, I can then get my oxygen. So I say 3.18 minus 2.54, and this will give me 0.64 grams of oxygen. Okay, so now remember we're looking for the formula of water, right? So let's just move a little bit down here. Actually, I don't want to zoom out. Just want to move down. Okay, cool. So now, if we've got water, the mass of water is equal to 0.72, and we know that, okay, we've got oxygen which weighs 0.64 grams. Then how does the oxygen form the water? Well, the oxygen combines with hydrogen, right? So what is the mass of hydrogen? We simply have to just minus these two, minus 0.72 from 0.64, and this will give me 0.08 grams. What is this mass of? It's the mass of the hydrogen, right? So again, when we want to work out if hydrogen over here and oxygen over here, if these two are combining together as elements to form water, what's the ratio of elements? What's the formula? Well, again, we have to use the masses that we've got, 0.64 grams, and we've got 0.08 grams here, and we've got to divide and work them out into moles, because we've got grams and we've got these elements that have a certain molar mass. So let's use that formula. So for both, okay, so we've got hydrogen, which is 0.08 grams. It's the mass divided by the molar mass. It's going to be 1. And then we've got oxygen, which is 0.64 divided by the molar mass, which is 16. And then we'll get our ratios of moles here, right? So we've got 0.08, and this is going to give me 0.04. Now remember, when we've got elements together and we've got two different mole ratios like here, or two different mole answers, we then divide by the lowest one. So this is going to give me 1, and this is going to, we divide by the lowest one, 0.04. This is going to give me 2, and therefore we can say that water's formula is H2O. Okay, it's important to know that in this experiment, obviously you guys know the formula for water is H2O, but if we didn't know that, and we worked with hydrogen, we worked with oxygen, and we got oxygen from this copper oxide, and we got hydrogen gas, then we can use this experiment to figure out the formula of water. And that's the purpose of the experiment, is to actually prove that water's chemical formula is H2O. Cool. That's all the experiments we're going to be doing for empirical formula. I hope it's been super helpful.